Okay, hello everyone. Today we have a Codeforces round, and this is a Div2 round, so it will be rated for me. And yeah, this one is organized by Triple IT Hyderabad, so like that's great. Yeah. So let's see how this one goes, and I'm also planning to do post-contest discussions with Parth. So if you don't know him, then maybe you can check out Parth 20 on Codeforces, and I'll show you that in just a minute. So yeah, he is the one. Yeah, 25 seconds more to go. And I hope my Sublime is working properly. So it takes a lot of time to build on the very first time. And I guess it's going to get started. Yeah. So let's see. Coming to problem A, and I hope I'm recording. Yeah, it is getting recorded. So taking a lot of time to load. And it has loaded. So the GCD sum of a positive integer is the GCD of that integer with its sum of digits. Okay. Denotes the GCD divisor, and for example, can find the smallest integer x such that the GCD sum of x is greater than 1. Okay. So can I just pick up any even number? Okay, that will not give me an even sum of digits in that case. Okay, let's see what are the numbers here. 11. And can I just do a brute force here? Like the sum of digits, can be 9 into 81, right? At max. 9 into 81. 9 into 18, sorry. And minimum it can be 1 into, like it can be 1, right? So I just want a number. I think a brute force should work here. Not sure though. I think it should, because at some point you'll have the sum of digits as even and the last digit will be even as well, right? So I think this should work. Okay, I'll just quickly turn off the vibrations here. Yeah. Oh, why did I just close it? taking a hell lot of time here. So yeah, I'm pretty sure this brute force should work. Because at some point you'll have your sum of digits as even. And what is this file? c.cpp. And the number will be even as well. Yeah, so it has worked on the pretests, and I'm pretty sure this will work. Because the logic is this only, that very quickly you will have the sum of digits as even, and the number will be even as well. So like you'll have your GCD as 2 in any way, but yeah, like that is the main logic here. So you're given n rectangles, each of height 1, each rectangle's width is a power of 2. Okay, it can be represented as 2 to the power x for some non-negative integer x. You're also given a two-dimensional box of width w. Note that w may or may not be a power of 2, at least as large as the width of the largest rectangle. It is able to fit all the rectangles in it. It is allowed to have some empty space left in the box after fitting all the rectangles. You cannot rotate the given rectangles to make them fit into the box. Moreover, into any two distinct rectangles must not overlap. Okay. The first line contains two integers n and w. The second line contains n integers w1, w2 up to wn, where wi is the width of the ith rectangle. Okay. Oh, okay. This is like the way it looks. So you are given the width. You're given the width. Okay. So if you can just place the biggest block here to the bottom and to the left, then what else can we do here? I think a very greedy solution should work here. Like I'm taking the biggest one, then again I take the biggest power of 2 that works. When will that not work? I think this should be fine. Like I take the biggest block first and I place it. Then for the remaining space again I take the biggest block and I place it. So like, is there a way that I don't include the maximum width block that can come here and I include it afterwards, but instead I include the smaller ones here and it works for me? Like, will there be a way? So if you are able to put, let's say, 2 to the power m inside here, then why not just put it? Like, what will be our loss in this case? All of these are powers of 2. This is something to note here. So like, if you can put x 2 to the power k is here in this part, and instead you are able to put, let's say, 2 to the power p, where p is greater than k. So should you put it here or should you not put it here? That is the point. And what I think is that you should put this block, the maximum one that is coming. Or rather, you should put a subset here that completely fills it. That will be a great greedy as well. Okay. So if I can just express W in terms of binary, then let's say W is something like this. So I should try to put this subset. That will be the best, like, because we are taking up the whole space, right? So we should try to put this here. But then I don't know. I think the most greedy solution should work here. Wi's are up to 10 to the power 6. So yeah, I can keep a count of the number of times each bit is coming. Yeah, first of all, I can keep that count. That makes sense. Or rather, let's keep it LL. Now, since this is only up to 10 to the power 6, we have to store only 20 bits. Like, yeah. Okay, I can just extract the log value here. So how do I get the highest bit that is set? I can take it as -1 because then it will be like 2 to the power 0. Yeah, let's try to see what are we getting in this occurrence variable. Okay, 1, 2, 4, and 8. Yeah, seems fine. So what if I just try to do the completely greedy thing? Let us start iterating from back, and I try to see how many times that bit can come in that variable, in that W. Yeah, so obviously there won't be a proof for that then. Yeah, I think this greedy should work. Like I'm not able to think of any other cases that defy this greedy, but every case that I'm able to think of right now is like in alignment with this greedy approach. So yeah. Okay. So I'm extracting the number of times this number can come into that W, into the remaining obviously. So then I do this. I don't know, I have this very strong feeling that this will work, but I'm still not sure because I haven't proved it. Okay, let's see. I'm submitting this one. Like I have this very strong feeling for this. But if it does not work, then yeah, obviously we'll have to think of cases. Okay, so it has worked, but there are only 5 pre-tests here. So I'm not really sure if this will pass the system tests or not. So yeah, like what I've done here is that, I've tried to put in the maximum number as many times as I can. And like that is a very clear greedy here. So let's see the problem C here. Okay, 7 minutes. You see the speed here. Gaurang has grown up in a mystical universe. He is faced by n consecutive 2D planes. He shoots a particle of dkHk at the planes. A particle can pass through a plane directly. However, every plane produces an identical copy of the particle going in the opposite direction with a dkh of k minus 1. If a particle has dkh equal to 1, it will not produce a copy. Okay. For example, if there are two planes and a particle is shot with dkh 3, the process is as follows here. Dx refers to a single particle with dkhx. The first plane produces a d2 to the left and lets d3 continue to the right. The second plane produces a d2 to the left and lets d3 continue to the right. Okay. The first plane produces a d2. Lets d2 continue on to the left and produces a d1 to the right. Okay. Pretty interesting. The second plane lets d1 continue on to the right. d1 cannot produce any copies. The final multiset is d3, d2, d2, d1. Cope up with the complexity of the situation when the number of particle planes is too large. Help Gaurang find the size of the multiset S given n and k. Since the sizes of the multiset can be very large, you have to output it modulo 10 to the power 9 plus 7. Particles can go back and forth uh, between the planes without colliding each other. Yeah, that's right. Test cases n and k. Okay, something like n into k should work here. What is n here? Uh, Faced by n consecutive 2D planes. Okay, he shoots a particular range at the planes of age k. Okay. So like if we look at it like this, then we have these many planes, right? Yeah, these are the planes. And if I fire a particle of, let's say, age k, then it goes here, it continues, and it continues, right? So this will always be there, okay? This will reach here no matter what. But when this reaches here, there will be, okay, does the first plane also produce a particle in that case? Okay, fine. So like if you see, So if I get something that is of power, I mean decay value k coming here, then k minus 1 will go here and get lost, right? So that will like add up 1 to my answer, right? Or can I like consider this question in the form of a dp, that if I am at this plane, right? If I am at this plane and let's say a particle of decay value k is fired on this plane towards the left of this plane, then what is the number of particles this will produce? Can I do this? Like then I won't count k obviously here because k is already counted, and then a particle of decay value k minus 1 will be fired here. So what I will have to do is I will have to find dp of n minus 1 k minus 1 and the particle is coming towards from the right side. Okay, so let's consider it in the form of a dp. Obviously I don't have a recurrence right now, so like my dp can look something like this, that I have dp of n comma k comma side. So if I am at let's say, if let's consider this n, if I am at nth block, then my dp of n comma k, if it was coming from the left, then I can consider it as 0. Then this will be 1 plus dp of n minus 1 k minus 1 and 1, right? And what else will I add to my answer? I will add dp of n plus 1, okay, n plus 1 comma k, because this will pass through, right? This will pass here, comma k comma 0, right? Yeah, and this won't add up another particle because we are using the same one. Okay, so that dp seems very fine to me, but like how do I calculate everything here? So to calculate dp of n comma k comma 0, what do I need? I need dp of n plus 1 k comma 0, and I need dp of n minus 1 k minus 1 comma 1. Okay, and similarly for, okay, let's do it here. For dp of n comma k comma 1, like it is coming from here, what do I need? I need dp of n minus 1 k comma 1, and I need dp of n plus 1 k minus 1 and okay, this is like a loop. If I do it recursively, then this might work, because I'm not able to think of the iterative structure that will look like here. I just hope I'm not creating a cycle in that recursion, because if a cycle is created, then obviously that is like an infinite loop. Okay, let's see what do we need here. So for dp of n comma k comma 0, I need dp of n minus 1 k minus 1 and 1, and I need dp of n plus 1 k comma 0. Similarly for dp of n comma k comma 1, I need dp of n minus 1 k comma 0, and I need dp of n plus 1 k minus 1 shouldn't this be n plus 1? Yeah, this should be n minus 1 only. N minus 1 k comma 0 and n plus 1 k minus 1 comma 1, right? So this is what I need. Like, so for I can calculate for every n no, I don't think this creates a cycle in any way. This is totally fine because for these 0 parts I am moving towards the right, and we will never return with the same 0 with the same n, k and 0 towards the left to calculate that value. Similarly for this 1 part, I'm always moving towards the left. I'm never coming back to that same value, and k is not increasing, k is always decreasing. Yeah, this should work. So this will be like an n into k dp. Okay, let's try it out. Or should I create a dp outside? Yeah, I should create it globally. So I'm not doing it recursively. I'm not doing it iteratively because like I'm not able to understand the whole flow. So it is obviously better to do it recursively, because then I don't have to care about the flow, right? J equals to -1. Fine. Then, so I am currently at index 0, and I have currently k here. Instead, I'm passing it to the one side, right? Yeah, this is 1 plus. One comma k comma, and I'm passing it from the 0 side. That is from the left side I'm coming. Yeah. If we are at the right side, okay, then I have two choices. N minus 1, I mean index minus 1, comma, k minus remaining minus 1, and we'll pass the if side equals to 0. Index plus 1, we'll pass the same remaining, and then this will become this. Index minus 1, then we have the same remaining, and then we have zero as the side. Yeah. Remaining minus 1 and yeah, but then there are cases here. Index plus 1 should be less than equal to n. Right, yeah, this is fine. Similarly, index should be greater than equal to 1 here, because then only I will rather it should be index minus 1 should be greater than equal to 1 here, because then only will I go there, right? Otherwise there is no sense of going there. Similarly, here we have, like if I'm coming here, Rather, I should just add them up like this normally, because I don't want to spend a lot of time in this mod part, because already this is a recursive function. Okay, let's see what is the issue here. So if it is not equal to -1, then we return that. If remaining equals to 1, let's do this. Okay, so if we are at the 0 side, oh, I'm not returning anything here. Still, it just gives me. Okay, 1 comma 2 comma. Oh my god, I'm not calling that function here. I don't know what I just did here. Okay, seems to be fine now for this part. I'm pretty sure this won't go into an infinite loop, because like for zeros you're only moving towards the right, and for like the ones you're only moving towards the left. So you're never returning to that same value with the same side and with the same k value. Yeah, seems to be fine. Okay, now let me just quickly check if I'm doing all the mod thing correctly, because I don't want this to fail in the system test just because of that. So yeah, it seems fine, and I'll quickly submit it. Okay, great. This was a very nice problem, I think. Really cool. And like I would love to solve it iteratively after this contest. Because like understanding the flow of this question iteratively is very difficult. Recursively we can see that there are no cycles, so like it won't go into an infinite loop and we are doing the right things. But yeah, doing it iteratively will be really fun. So moving on to problem D now.